Well, by now you have already watched Bill Nye explain a bit of the atmosphere, but now we're going to go a little bit further into some notes about the atmosphere. So it's your job to pull out assignment number 1, Earth's atmosphere. And then the first thing I want you to do is I want you to move those rings around Earth in number order. Now these rings, as you move them around the Earth, it starts to create something like a glow. Now this glow is actually the atmosphere, and no, our Earth does not glow. In fact, a better view of our Earth kind of reveals it to look something like this. You can see the blueness of it, and almost like there are layers inside of this atmosphere of our own. Those layers are layers of gas, and each layer has a different name. So what we would have done, and we'll do it when I come back, is we'll do something really cool with a trash bag and a vacuum cleaner. But in order to get there, what we're going to really start with is understanding air has something, and what it has is air has pressure. That's right, air has pressure. I want you to type that in on this slide. How much pressure? Well, 14.7 pounds per square inch. That's like almost 15 pounds of pressure per square inch that pushes on every inch of your body. So if you had 10 square inches, that's 147 pounds. If you had 100 inches, that's 1,470 pounds of pressure, air pressure pushing on your body. The only thing is we don't feel it. Now, what is the atmosphere? Now, our atmosphere is actually layers of gases that surround Earth's surface. I want you to type that in. There's 5 different layers. There's the Troposphere, the Stratosphere, the Mesosphere, the Thermosphere, the Exosphere. If the sub needs to stop or pause at this moment, feel free to, so that way you guys can get this information typed in. Now, if I gave you a better view of it, a better view would look something like this, and I want you to notice the picture. If you look at the rods, there's ice on those rods. They used to be yellow, but in this layer, which is known as the stratosphere, this is right around the area that airplanes fly, and it's very cold. In fact, the temperature starts to drop as you go up. This is the view from about 99,000 feet above the air, which is pretty incredible to look at. In fact, it's my background of my computer at home. Here's another view from about 98,000 feet that we took with a weather balloon that I launched every year for the last 3 years. And so now we're going to look at the different layers or the different spheres of the atmosphere, and I want you to type these in with the notes. The first layer is where we live, and it's called the troposphere. It's the area and the lowest area where we live. Then there's the stratosphere, which is actually just a bit higher than most airplanes fly. Then there's the mesosphere. Now, if you want to get to the mesosphere, you're going to need a rocket, because that's about the only thing that can make it to the mesosphere. The fourth layer is called the thermosphere, and there's a reason we call it thermo, because it's really hot. If you look at that red line on this diagram over on the side, you'll notice the temperature drops and then it increases dramatically in the thermosphere. I mean, it goes up to 1,727 degrees Celsius, which is really, really hot, and that has a lot to do with the sun's rays. Then the final layer, which is the highest layer up, it's known as the exosphere. Once you're past the exosphere, there's very few people that have made it that far. So let's start by talking about the troposphere. Now, the troposphere makes up 75% of the gases on Earth. That means most of our air is right down here where we live. It starts right on Earth's surface. Now, the height that it goes to about 8 to 14.5 kilometers. That's about 5 to 9 miles. If I were to take Mount Everest and stand it straight up, Mount Everest is 6 miles high. So in fact, the troposphere, Mount Everest never even reaches out of it. This is also the most dense part, meaning this has the most air packed into a very small area. The last part that you need to know is that this is almost all weather occurs in this region. That means all of our thunderstorms, all of our rain, it happens in the troposphere. The next layer is called the stratosphere. This makes up for the 24% of our gases. Now, there's not enough air to breathe up in the stratosphere. I mean, the stratosphere is a lot bigger than the troposphere, but on top of that, it has a lot less gas, which means we don't have the ability to breathe up there. It's just above the troposphere, and it extends up to about 50 kilometers. That's 30 miles high. So if you take Mount Everest, the tallest mountain in the world, and stack it 6 times higher than Mount Everest is how high up you would go. Now, this also contains something called the ozone layer. Now, the ozone layer is incredibly important. This ozone layer, as you're looking at it on the screen here, it stops and scatters out the solar radiation. Without our ozone layer, we die. And so it's incredibly important that the stratosphere has this ozone layer. The next layer is the mesosphere, and it's less than 1% of all of our gases. Now, what's interesting is you still can't breathe in the mesosphere. In fact, it's just above the stratosphere and it's extremely cold. It extends up to 85 kilometers or 53 miles high. That's taking Mount Everest and taking 9 of those Mount Everests and stacking them on top of each other. That's how high up the mesosphere is. But it has a very important role. You see, when meteors fly in and they start hitting air, it creates friction, kind of like how you rub your hands together. And these meteors burn up in this layer. And so this layer is actually responsible for helping protect us from giant meteors. Some meteors come in the size of a bus, and by the time they leave the mesosphere, they're the size of a basketball, which is still going to hit us, but it's not going to hurt as bad. Here's another example of the mesosphere, just to show you how much the temperature on that red line, how much it actually drops. Then you have the thermosphere, which starts just above the mesosphere. Now, there's so little air here that I'm not even going to give you a percentage because it's so small. There's no breathing in the thermosphere. The only way you're getting there is if you're using a spaceship or some type of rocket that can propel you that high. It's up to 600 kilometers. That's 372 miles. Going back to Mount Everest, if you took Mount Everest and did 60 Mount Everests, that's how high the thermosphere is. There's 2 things found here, auroras, which we'll talk about in another lesson, and then there's something called satellites. And you guys know our satellites, the International Space Station can be found here. All of these are located inside of the thermosphere. Here's another example of the thermosphere to see how much the temperature rises. In fact, thermo means heat, and in the thermosphere, it gets very, very hot. And so the reason behind that is all those solar rays that we talked about that the ozone layer protects us from, the thermosphere is getting hit by all of those. And therefore, there's a lot of high temperature. There's large temperature fluctuations, it says here, meaning at some points it could be really cold, and at other points it could be extremely hot, depending on the amount of radiation. Then there's an invisible layer known as the ionosphere. Now, why would I tell you about an ionosphere? Well, simple. It's in between the mesosphere and the thermosphere. So you're looking, and there are 2 spheres there, and it's located in between, but it's invisible. In fact, it's not made of air. The reason we talk about the ionosphere is because it makes radio communication possible. In the ionosphere, there's all these little hard particles or little atoms, as we like to call, and they're very, very tiny. And what they're doing is these atoms are bouncing through the air. And as we send radio signals up, those radio signals bounce up and down through the air, and the atoms are ionized, which means they're able to shoot that signal across to different atoms, and it gets sent radio signals across the world. So when you turn your car on, you could thank the car radio on, you could thank the ionosphere for the fact that it works. Don't believe me? Well, go look at a radio tower and look at the direction that the radio dishes are pointed. They're pointed up. They're pointed up, not out, not down, not at us. They're pointed up in the ionosphere. And that's why we have radio. And the last layer, which is our highest layer, is known as the exosphere. Now this one is the upper limit. Very few people have ever been past or even into the exosphere. Most astronauts, they don't go this high. The only ones that have gone this high are those that have gone to the moon. And so you can sit there and say, well, Mr. Gilliam, how can, you go into space but still be in Earth's atmosphere? You could still be in space, but you're still got particles of Earth's air around you. Even though you can't breathe it because they're so small, they're still there. This one extends up to 10,000 kilometers. In the exosphere, there's no air that you can breathe. The only air we have is what's found down in our troposphere. So these are the layers of the atmosphere. Feel free to go back if the sub needs to fill in ones that maybe you had missed. But your goal here is to take these notes because you're going to need them a lot later this week when we start talking more about an activity called How High Is It?